Welcome back to the deep dive, where we, try to understand some pretty complex stuff. Today we're diving into, well, a pretty big one, microbial resistance.
Antibiotics and antimicrobials, yeah.
Right, right. So basically how these little bugs can actually just kind of shrug off the drugs we throw at them.
Exactly. And this isn't just some like niche scientific thing. I mean, it's a massive global health problem.
For sure.
I mean, when microorganisms become resistant treating infections, it gets way more complex.
Right.
And that, of course, can lead to more serious illness. And we can't forget the costs.
Oh, yeah. Healthcare costs go way up.
Huge problem. So we're going to look at the different ways this resistance develops, and the tactics that microbes actually use.
Okay, so like right off the bat, it looks like there isn't just one way that microbes develop resistance.
No, not at all.
Our sources talk about natural resistance or intrinsic resistance.
Right, so that's the microorganisms' like inherent ability to resist certain drugs. Just part of their makeup. Think of it like, a species just having this natural defense.
Got it. And then we have acquired resistance.
Mm-hmm.
So I'm guessing that's something they pick up over time?
Exactly. Yeah, this is where a microorganism, develops resistance usually through changes in their genes
Okay.
in response to being exposed to an antimicrobial. It's basically evolution on fast forward.
Wow.
Yeah. And this is a big reason why some of the older antibiotics, they're becoming, less useful.
Right, right.
And we're forced to use these newer ones, which are, of course, a lot more expensive.
So they're adapting. We're trying to keep up.
That's it.
Now, what about cross-resistance? What does that mean?
So this is, if a microbe becomes resistant to one type of antimicrobial, it can become resistant to others that work in a similar way.
Oh, okay. So the same vulnerability, you're saying.
Exactly. Yeah, same vulnerability, multiple drugs affected.
So that really shrinks our options, huh?
Oh, yeah.
And then finally, we have multi-drug resistance, or MDR. MDR. And it sounds like it's kind of the worst-case scenario.
It really is. This is when a microorganism is resistant to multiple classes of antimicrobials.
Oh, wow.
You can almost imagine like a fortress, right, with all sorts of different defenses.
Right.
And they're all working really well. So understanding these different categories, I think it really gives you a sense of the scale of the challenge we're dealing with.
Absolutely. So those are the categories of resistance.
Yeah.
But what are the actual tools, the mechanisms that they're using?
Right. So this is where it gets really interesting. One of the key mechanisms is called enzyme inactivation.
Okay.
So the microbe will actually produce these enzymes that can break down the antibiotic molecule itself.
So it's like dismantling a weapon before it can even
Yeah.
be used.
Exactly, like completely disarming it.
That's pretty ingenious
Mm.
in a scary kind of way. What else?
Target modification. So a lot of antibiotics work by, binding to a specific target within the microbe. The microbe can actually change this target, so the drug can no longer bind to it.
So the key doesn't fit the lock anymore.
Perfect analogy. Yeah, the lock has been changed.
Makes sense. Now, our sources also talk about F-Flex pumps. What are those?
Yeah, so think of those as like tiny pumps. They're within the microbial cell, and they basically actively just eject any antibiotic that manages to get in.
Oh, wow.
So they're like little bouncers. You're out of here.
Get out!
Exactly. And some microbes can even reduce their permeability, so making it harder for the antibiotic to even get in the first place.
So thicker walls, basically.
Yeah. Think of it like, yeah, thicker walls.
So it's either get out or you can't even come in the first place.
Right.
Okay, and the last mechanism is bypass mechanisms.
Yes. So if an antibiotic blocks like a key metabolic pathway in the microbe,
Right.
some of them can actually develop a completely alternative pathway to get the same result.
It's like finding a detour.
Exactly. The road's blocked, we'll just take a back road. So, all of these different adaptations really highlight this constant evolutionary pressure that's going on.
So we're facing a huge problem with AMR.
Mhm.
We've got different types of resistance. We've got inherent abilities, and we've got resistance against multiple drugs.
Right.
And then we have all of these different mechanisms, destroying the drugs, changing their own internal workings.
Exactly.
It's an amazing battle.
It really is. It's a constant innovation battle.
And it makes me wonder, and I want you to think about this too, with all of these different mechanisms, with all of these different tools that the microbes have to fight back, what do you think are some of the biggest obstacles to actually coming up with new, effective antimicrobial drugs.
Mhm.
How do we get ahead of this? How do we win this battle?
Yeah, that's the million-dollar question, isn't it? It really is.
It is. So think about that and join us next time for another deep dive.
See you then.